your computer can work with these numbers. They can store these numbers. They can do arithmetic on these numbers, and it's no issue at all. But if an attacker, and this is assuming that brute force attack is the best that you could do, and as I say, that's an open problem. Any one of you guys who are clever could figure out a better way to do this computation without having to use brute force. But if you assume that brute force is the worst that it can be, the best attack that can happen, then even if you had all the computers in the world running flat out for 100 years, then you still wouldn't be able to break the system. It would still be secure. So the magic here, what I'm hoping I'm able to convey here is the magic of how big numbers are surprisingly easy for a computer to work with, even though to test every single one of them would take way more time than any of us would be willing to sit around for. Maybe you're more patient than me. I'm not willing to wait 100 years. I'm not willing to wait. Okay, so let me wrap up. So what have we talked about today? So what I want you to get away from this is that there's incredible need in the future for math majors and an incredible need for people who are willing to talk about computer security and to think about these matters. So what I want you to think about is that computer security is incredibly important going into the future. There's very much going to be an increased need for people who are good at computer security as it's only becoming more and more important. The second thing to get out of this is that the major to have if you're thinking about computer security would be math or computer science. That would definitely be a good major to have. So we need math and CS majors. And the last thing that I want to get out of this is the important role in mathematics. That what I'm doing here is all mathematics. I'm trying to develop systems, I'm analyzing systems, I'm trying to compute things. I'm looking at how big numbers are and trying to balance that against real-world costs and needs. This is what mathematicians do. So these days, cryptography is all mathematics. So thanks very much for your time, everybody. So what we're going to do now, I think there might be a little bit of a break, otherwise we're moving, we're all good. Okay, so next we're going to be looking at the award ceremony, and you guys can get awards for the good work you've done today. But thank you very much for your time.